Consider the equation fx is equal to 2x power 7 minus x power 5 plus 4x cube minus 5 is equal to 0. So using Descartes rule, I am explaining. First step is signs of fx. What is first term symbol? Positive. What is the next term symbol? Minus. What is the next term? Plus. What is the next term? Minus. So how many changes? First change, and minus 2 plus second change, and again third change, plus 2 minus. That means, implies there are 3 sign changes, 3 sign changes in fx. F of minus x now is equal to, just substitute x is equal to minus x in fx, minus 2x power 7 plus x power 5 minus 4x cube minus 5. So in this I am writing signs of f of minus x implies. So this is first sign is minus, second sign plus, third sign minus, fourth sign minus. This is the first change. This is another change, plus 2 minus. Here minus 2 minus, no change. So from this we conclude there are 2 sign changes in f of minus x. Copy down. Hence, the equation cannot have more than 3 positive roots and 2 negative roots. Just this is less than or equal to means cannot have more than. That is not greater than. That is also pronounced as cannot have more than. That means number of positive roots less than or equal to 3, number of negative roots less than or equal to 2. That is the meaning. Number of positive roots less than or equal to 3, number of negative roots less than or equal to 2. This is the procedure. Note, if an equation of nth degree has at the most p positive roots and at the most q negative roots, then it follows that the equation has at least n minus of p plus q imaginary roots. Suppose take seventh degree equation. It has maximum 2 positive roots and maximum 3 negative roots. So, 7th degree means n is equal to 7. P stands for 2 positive roots. Q stands for, say, 3 negative roots. Now, how much? 7 minus 2 plus 3? That is 2nd degree. That means finally 7 minus 2 plus 3 gives 2 only. That 2 roots must be imaginary. And remember, imaginary roots, that is complex roots, are always occur in conjugate pairs. Irrational roots and imaginary roots are always occur in conjugate pairs. That means, suppose while solving, if you get 1 plus I, automatically other root is 1 minus I. Suppose while solving an equation, if you get root 2, square root 2, then automatically minus root 2. Okay, like that. Now I am going to one by one method in the first topic, that is solution of nonlinear algebraic or transcendental equations. So of all the 4 methods, Newton-Raphson method is the fastest method. Convergence is going fast, that is within less steps we get the answer. So that's why that problem is given many times in all the branches. Okay, out of 10 times, 8 times the problem is given in the Newton-Raphson method only. Okay, so anyhow I am going to start first bisection method. So this is also known as Bolzano's method, Bolzano scientist, or interval halving method. Bisecting means the meaning of it is midpoint. Okay, let fx be continuous function in closed interval a comma b such that f of a and f of b are of opposite signs. And the next step, let fa less than 0 and fb greater than 0. Or suppose then there exists at least, this is intermediate value theorem only, one root between A and B. Now I am giving the procedures. Let x1 be the first approximation root to fx is equal to 0 and x1 is equal to a plus b by 2. Case 1. If f of x1 is equal to 0, then x1 is root and stop the process. Case 2. If fx1 greater than 0, then compute x2 using x2 is equal to a plus x1 by 2. That is, root lies between BET, in the power position I am writing n, that stands for between a and x1. Since fa we have assumed less than 0. Okay. Now what is the diagram here? This is the end point A. This is another end point B. Bisection method midpoint, that is x1. Here we have assumed fa less than 0, fb greater than 0, fx1 greater than 0. So whenever two consecutive values, this is neglected, this is included. I will explain. First, copy down. Case 3. That is for understanding only the diagram. If fx1 less than 0, then compute x2, using x2 is equal to x1 plus b by 2. That is, root lies between x1 and b, since f of b greater than 0. In this case, this is a, this is b. fa less than 0, here I assumed fb greater than 0, here I have taken fx1 less than 0. Now, this is not required to explain, it is already given intermediate value theorem. Choose two starting values or initial approximation values to the required equation, say a and b, then closed interval ab is formed. That means you choose two values a and b. I shown you in one of the problem location of the roots, such that fa, fb are of opposite signs. Here I have supposed fa less than 0, fb greater than 0. This is also true for all these results, are true for fa greater than 0 and fb less than 0. Okay. Now, then there exists at least one root. It is not required to explain. This is I already explained in location of the root. I mean Descartes' rule of sign. Not Descartes' rule of sign, intermediate value theorem. Now, this is your first step onwards. Your first approximation value denoted by x1. x0 is 0th iteration, that is initial approximation value. In some problems that there are two initial guess values to be taken, that is say a and b or x0, x1. Okay, in some problems only one initial approximation value or starting value or guessing value, like that. x0 is initial approximation, x1 is the first approximation root, like that. x1 is the first approximation root. How to find x1? Because I said this method is bisecting, that is midpoint method, a plus b by 2. This is your first x1 values. That means by finding all these 1 by 1 x1, that means you are going on, you will be getting 1 by 1 x value. Okay, where do you stop? I will tell you the procedure. So once you get first root approximation by this, there are three cases. Whenever you get an x value, latest x value or latest iteration or latest approximation, immediately substitute that x value in the function fx. That function has three natures. That function value is either 0 or less than 0 or greater than 0. That means take any fx, substitute some x number. That fx value is either 0 or less than 0 or greater than 0. No other nature. Only three natures. Less than 0, greater than 0 is equal to 0. Whenever fx1 0, that means x1 satisfying this equation, so x1 is root and stop the process. Whenever fx1 greater than 0, so here fa less than 0, we already took fa less than 0. Here I am assuming fx1 greater than 0. Whenever two function values are of opposite signs, then intermediate value theorem tells that required root lies between a and x1. That means in the stage 1 is your interval is a comma b. So by going on that one by one step, your interval reduces. Whenever your interval is not reduced, it is extracted, it is extending, then your problem is will not get, that means you will not get the answer. Your problem is going to divergent. Your interval should be decreases. For example, in the stage 1 is your root lies between 1 and 2. In the next stage, it should be reduced 1 and 1.5 or 1.5 to 2, like that. Okay. So when we are going by one step, your interval should be reduces. Then only you will get the root in some stage or some iteration. Okay. So if fx1 greater than 0, then compute x2 using x2 is equal to a plus x1 by 2. Why should you use? I use this formula. Here a function value less than 0, x1 I took greater than 0. These two are of opposite signs. Your final answer, that is root lies between a and x1. So whenever a root lies between two numbers, your bisection method, midpoint method tells that midpoint of the two numbers. That is a and x1 midpoint is a plus x1 by 2. Case 3. If here fx1 greater than 0. Here I am going to assume fx1 less than 0. So then in the previous case, which is greater than 0, fb greater than 0. That means at every case, at every stage, you find or search two function values which are of opposite signs, then your final answer lies between their corresponding a values. So every stage your interval, location of the root changes. What is location of the roots? Two function values are of opposite signs, then your answer lies between, your answer means your root lies between the two corresponding numbers. That is called location of the root. So every stage your location of the root, that is you will be getting new interval. How do you get new interval? The corresponding function value should be opposite signs. Okay. Then root lies between x1 and b. So in this case compute x2 using midpoint method, that is x1 plus b by 2. So this is first iteration only, x1 having three cases. Like that every iteration x2, x3 also three natures. Where do you stop the procedure? Until to get the required degree of the accuracy. Until to get the given accuracy. That means accuracy means your accuracy means increases when you are going to do more number of iterations, third iteration, 10th iteration, 11th iterations. Bisection method takes generally 99% problems more number of iterations only. This method going slowly, that means this method slowly converges. But even though you will be getting the answer, but it is going slowly. After lot of iterations, lot number of steps, you will get the answer. Okay, this method converges slowly. Okay. So every stage you will be getting a x value, immediately find its f value and decide one of the three cases 1, 2, 3. Okay. In every stage, in every iteration, you will be getting a latest interval, closure interval, that is two numbers whose function values are of opposite signs. Then your final answer, that is root, lies between in that latest two x values whose function values are of opposite signs. Just here I am going to explain. In this case fx1 greater than 0. These two are of same signs. Then your final answer does not lie between in this closed interval. I told you your closed interval, first iteration a and b is always going to reduces when we are moving one by one step. Okay. So in this fa less than 0, fx1 greater than 0. So your next, in this step, your x2 value lies between here. So all of you write, in this case, I forget to write, in this midpoint x2. In this case, fa less than 0, fx1 less than 0. So this is excluded. Your final answer not lies in this interval, your final x value. But here, this is less than 0, greater than 0. Your final answer lies between x1 and b. In the next step, your midpoint x2 is x1 plus b by 2. All of you here plot x2, here also plot x2. However, this method is guaranteed to converge and it is not obtained, it is not useful for finding the imaginary roots. This method converges slowly. After lot number of iterations we get the answer, but finally you will get the answer. Okay, so this method converges slowly only. In only one or two problems, few number of problems, you may get the answer in second step, third iteration, fourth iteration, like that. Okay, so first one problem is, this is given 2012, 2 marks. The bisection method is applied to compute a zero of the function fx is equal to x power 4 minus x cube minus x square minus 4 in the closed interval 1, 9. The method converges to a solution after how many iterations? That is, it is fill in the blanks is given. Anyhow, I am going to give the options. A1. It is not a fill in the blanks, options only. First of all, solution means root of the equation. Okay. This method is applied to compute a zero of the function. What is the meaning of zero of the function? Nothing but root of the equation. Zero of the function is also called root of the equation. So this equation is converges to a solution by this method after how many iterations? Okay. Fx is equal to x power 4 minus x cube minus x square minus 4. A is equal to starting values, 2 initial guess values, A is equal to 1, B is equal to 9. So what is F1? Whether it is, see, whether irrespective of A comma B, you immediately find FA, FB function values. Then only we can come to, then only we can conclude, we can come to the conclusion, the final answer, that is root, lies between these x values, F1. So this gives 1 minus 1 cancel, minus 5 less than 0. F9. So 9 cube, 9 power 4 minus 9 cube minus 9 square minus 4, whatever it may be, it is greater than 0. Okay. But this method does not depend on the function values, it depends on only the signs. Signs means plus and minus only. Okay. See, that means one by one, if you are going one by one step, that is x1, x2, these values does not depend on fx values, function values, but they depend on signs only. So therefore, root lies between 1 and 9, which is given correct. The two initial guesses given correct in the problem. Now, by BM, BM means bisection method. What is x1 formula? A plus B by 2. What is the midpoint? 5. So whenever you get an x value, you immediately find its function value. Then it has three natures: is equal to 0, less than 0, greater than 0. Just I already explained. Please refer the procedure. Fx1. That means 5 cube, 5 power 4, 625. 5 cube, 125 minus 25 minus 4. Whatever it may be, I am not simplifying that, but I can say greater than 0. So here this latest function value greater than 0. Now you find the one of the previous function value less than 0. Then only your final answer lies between the latest two x values. That means your interval 1, 9. In that way it is reducing. Okay, whenever it is going to reduces, whenever it is reduces by one by one step, we can get the final answer. Okay. F1 how much? Less than 0. Implies root lies between. For understanding purpose only, once again I am writing F1 nature and these sentences 1 and 5. So therefore, what is your x2 formula? Latest midpoint, that is latest closed interval, that is 1 comma 5. Your interval 1 9 is reduced to now 1 5. 1 plus 5 by 2. This is 3. Immediately find its function value. 3 power 4 81, 3 cube 27, 3 square 9 minus 4, whatever it may be, I am not simplifying, but I can say greater than 0. So again, in all the previous iterations, you find the latest function value less than 0. So in the previous case, in the previous steps, we have only f1 less than 0. That is your latest interval, that is root lies between 1 and 3. Your closed interval first step 1 9, in the second step 1 5, now it changes to 1 3. This is called reducing 1 by 1 step. In 1 by 1 step your interval should be reduced, then only it is going to convergent, you will get the answer, otherwise it is going to divergent. Therefore x3 is equal to 1 plus 3 by 2, that means 2, and f of x3 2 power 4 16, 2 cube 8, 2 square 4 minus 4, this is simplifies to 0. Therefore x3 is root, x3 is equal to 2 is root of the given equation. Okay, but the question asked after how many iterations, but the question not asked what is the root of the equation. Okay, therefore the method converges after how many steps, how many iterations, we got the answer. Converges to a solution means you should get definitely the answer, one of the roots of the equation. So this will happen after third iteration only. Okay, we got the root 2, that is solution of the equation, after how many steps? 3 steps. The method converges to a solution after 3 iterations. So this is the first problem. I think I told you 95 to 99% problems bisection method takes a lot of time. This is one of the problems takes less time, less number of steps also. Newton-Raphson method, which is also known as method of tangents. So whenever you are go on doing these steps, your interval should be reduced in this method. Okay, otherwise your problem is going to divergent, you will not get the answer. So at every x value, at every latest x value, you immediately find its function value and decide the nature, means is equal to 0, less than 0, greater than 0. Then only we can conclude, we can discuss that next step. We can able to find the next step, next iteration. Newton-Raphson method, which is also called as method of tangents. Let fx be a continuous function then NR stands for Newton-Raphson. Iterative formula, that is stepwise, one by one step we are finding one by one x value, that is called iterative formula. For solving instead of solving, better to write the word finding. Finding the root or a root of the equation fx is equal to 0 comma is xn plus 1 is equal to xn minus fxn divided by f dash xn. In particular, that means here n is equal to 0, 1, 2, so on. For n is equal to 0, comma x1 is equal to x0 minus fx0 divided by f dash x0. x0 is starting value or initial approximation approximation root. Okay. In some textbooks, this iteration formula is given as xi plus 1 is equal to xi minus fxi divided by f dash xi for I is equal to 0, 1, 2, so on. Now the iterative formula for solving this equation, but I didn't give the iterative formula directly in bisection method, that is one by one step means automatically it is bisection midpoint only, that's why not required iterative formula. In this xn plus 1, xn is equal to xn minus fxn by f dash xn. That means at every x value, at every iteration, you need to find two function values, f value and its derivative. Okay, or in some textbooks ith notation, in terms of I symbol, here in terms of n symbol. If you take n is equal to 0, this is your first approximation root, that is x1 given by this value. x0 is initial approximation root or starting value. If xn and xn plus 1 values are same or difference between xn and xn plus values is negligible, that is very small, comma, then stop the process. So what is xn and xn plus 1? Here first step we got x1, next step x2, next step x3. Like that you find whenever two consecutive x values, say x2, x3 or x3, x4, in general xn and xn plus 1 are same, or difference between two consecutive x values is very small, that is negligible. Suppose your x1 value is 0.001, your x2 value is 0.002. The difference is very negligible quantity, small quantity. In such cases, stop the process. Or whenever two consecutive x values are small, are same, then stop the process. Okay. In the bisection method, continue the bisection method process until the desired accuracy of the root is found. Desired accuracy means depending on the situation of the problem, up to 3 decimal places, up to 2 decimal places, it will mention. Or depending on the other sentence of the problem, you stop the bisection method procedure. That is called until the desired accuracy of the root is found. That means do up to 3rd iteration means that is desired accuracy, like that. So at every iteration, that is per iteration per step, we need to evaluate. One is f value and its derivative. 2 steps. I mean 2 function values we are evaluating. See, I am proving this one. Suppose a curve like this. Okay. X-axis, origin, y-axis. This is curve. After taking all terms on one side denoted by fx from the equation. So this is your final answer because the curve crosses the x-axis. Whenever it meets x-axis, there you will get alpha, a root of the equation. Root. Your x0 is, take here, initial approximation. So immediately the corresponding x and y values are obtained. Let us say p coordinates x0, fx0. Whenever you get x value, how to find a y value? Substitute that x value in the function. After getting y value, plot x and y that point wise in 2D case. Okay, then only you will get this curve. After getting all one by one x value and y value. So why it is called method of tangent? Now draw the tangent at this point. Okay, so this tangent meets x-axis, let us say x1. Okay, now see. Equation of the tangent at px0 fx0. In calculus, I have given equation of the tangent at px1 y1. y1 is nothing there. X1 is here, x0. y1 is here, f of x0. What is that? Y minus y1. y1 means y coordinate of that point is equal to f dash x at that point. F dash x at which point? x0 starting value into x minus x1. What is the x1 x coordinate of the point? That is x0. Say equation 1. Okay, so here x0 is initial approximation. Okay, now this equation 1, that is tangent at p, again meets the x-axis at x1. That means this tangent is also passes through the point, this x1 0, and equation 1 passes through the point x2 comma 0. In x2 what is y coordinate? Sorry, x1 comma 0. In x1 lies on x-axis, that is automatically y coordinate is 0. Comma, we get just in the above equation substitute y position 0, x position x1. 0 minus fx0 is equal to f dash x0 into x means x1 minus x0. Because we are going to find x1s, bring all other terms in the right side into the left side. So first of all x1 minus x0 is equal to minus fx0 divided by f dash x0. Therefore x1 is equal to x0 minus fx0 divided by f dash x0. That means for proving purpose, that means how we got, that is x1 by which is called method of tangents, Newton-Raphson method, I proved in this way. Similarly, draw the tangent at x1 onto the curve. Again, at x1 find the corresponding fx1 value and plot that point on the curve, and then draw the tangent at that point like this. You will get x2, x3, so that while finding, that means while solving one by one step, you will be getting 1 by 1 x1, x2. The tangents also somewhere after some time it is very closely to this alpha, that is called, after some stage, this iteration procedure, okay, will almost equal to your exact answer alpha. Okay, so that means at every step you will be getting the latest x and y values. Immediately draw the tangent. Somewhere the tangent, after some time, the tangent will coincide with alpha. That means that is exact root. Alpha is the exact root. Just for understand purpose only, how do we get that is x1, I proved in this way. Okay, that's why this is called method of tangent. Whenever a curve is given, a tangent is drawn, that is one approximate root value. Similarly, second tangent is given, that is second approximate value, like that. Okay, in some problems, if a curve along, that means a diagram like this given, then what is your first x0, what is your first x1, what is x2, what is x3 value? That means at each tangent, okay, you find the corresponding x value. Whenever a tangent meets the x axis, you will be getting that corresponding x value. So this method is a faster method than all other methods, because this is going to complete in all the problems. Okay, 3 to 4 iterations. If you look at your what we have done, what you have studied already in BTech first year, that Newton-Raphson method, it is the fastest method. That is the convergence very fast compared to the previous methods or all other methods also. This is a good method which gives your root in 3 to 4, maximum 7 steps only. Okay, like that. So one problem I am going to do. Example 1. Other problem I am giving you, later you do along with answer. 2012. If the initial guess is 0.5, initial guess for the root is 0.5, of the equation x minus cos pi x equal to 0, 0 less than or equal to x less than or equal to 1, then the root, then the value of x after first iteration is solution. So the value after first iteration means, after first step means what we will be getting x1 answer. That is, you need to find x1 value. So here fx, x minus cos pi x, and x0 is initial guess, that is taken to be 0.5 or 1 by 2, and your answer lies between here 0 and 1. That is the indication. Immediately find its derivative, f dash x. X derivative with respect to 1, cos derivative minus sign, so pi comes out, pi sine, not pi comes out. I told you while differentiating, multiply the constant inside constant. So pi sine pi x. Now f naught stands for f of x naught. So substitute here 1 by 2 cos 90 0. F naught dash, that means f of f dash x naught. Substitute x naught here 1 plus pi sine of pi by 2 sine 91. So 1 plus pi value 3.14 up to 2 decimal places. This simplifies to 4.14 by NR method, that is Newton-Raphson method. Method is mentioned. Oh, sorry, here then the value of x after first iteration using, please add this one method, NR method, comma is. By NR method, what is x1 formula? X naught minus f naught by f naught dash. F naught dash means f dash of x naught. So what is x naught? 0.5. What is this? Also 0.5, and this is 4.14. This is simplifies to 0.379 according to choice. Each choice is expressed in up to 2 decimal places. So here I have given 3 decimal places because the choice are given 2 decimal places. If the third place is greater than 5 or equal to 5, add 1 to the previous digit. If the third place is less than 5, then discard the digits there onwards. Okay, that is called rounding error, rounding the digits. Okay, you know, rounding the digits. Each option is expressed in terms of 2 decimal places. That's why here third decimal place greater than 5, I added 1 to the second digit. Okay, 1 to the second digit.